Hello, my name is Kazuki Matsuda from Keio University, and I will be presenting VELA, an LLM hybrid-as-a-judge approach for evaluating long image captions. So, let me start by outlining our contributions. First, we introduced LLM Hybrid-as-a-Judge, a fast evaluation framework based on late fusion of text and image. Second, we proposed VELA, an automatic evaluation metric for long captions that was 5 to 8 times faster than existing LLM-as-a-Judge. VELA achieved state-of-the-art performance and even surpassed human evaluation. Third, we constructed LLM-Arena, a benchmark for evaluating and training long caption metrics. This benchmark contained captions averaging more than 100 words, and it included 30,000 human judgments collected from 1,000 annotators. VELA and LLM-Arena are both available through the QR code on the slide. Now let me explain the motivation behind this work. The goal of this work is to develop an automatic evaluation metric for multimodal large language models. In practice, most MLLM evaluation still relies on metrics such as CIDR. However, for very detailed captions that often exceed 100 words, these metrics show correlations with human judgments of less than 0.1. In other words, their scores are almost meaningless. LLM-as-a-Judge can handle long text better, but evaluating it on a standard benchmark, such as no caps in Cocoa, can take more than 3 hours. This makes it very costly. Therefore, in this work, we aim to develop an alternative approach that can evaluate long captions both effectively and efficiently. Our target task is automatic evaluation for long image captioning. The inputs are an image, a candidate caption produced by an MLLM, and human annotated reference captions. Based on these inputs, the metric produces 3 evaluation scores from 3 perspectives: descriptiveness, relevance, and fluency. These 3 perspectives are standard in image caption evaluation. The goal here is for these scores to be close to human judgments. Before introducing VELA, let me outline the LLM Hybrid-as-a-Judge framework. In a conventional LLM-as-a-Judge, image and text embeddings are concatenated before input to the LLM in an early fusion manner. This increases sequence length and, combined with autoregressive decoding, slows down inference substantially. To address these issues, we proposed a fast LLM-as-a-Judge framework based on late fusion of text and image. In this LLM Hybrid-as-a-Judge, text and image are processed by 2 lightweight branches, and their outputs are fused afterward. VELA is a metric built on this framework. It has an R2C LLM branch, which evaluates a candidate caption against the reference captions, and an I2C align branch, which evaluates the candidate caption against the image. Here on the right is the VELA architecture. As you can see, VELA mainly consists of 2 branches. The blue part shows the text-only R2C LLM branch, which takes the candidate and reference captions as inputs. We use the text-only LLM Qwen 2.5 in a non-autoregressive manner to extract features. This avoids early multimodal fusion and autoregressive inference, enabling faster processing than LLM-as-a-Judge. The red part shows the text-only R2C LLM branch, which takes the candidate caption and the image. We first extract features from both inputs with LLM-Clip. We employed LLM-Clip because the original clip can only process up to 77 tokens, while LLM-Clip is designed to handle up to 248 tokens. Then we compute element-wise differences and Hadamard products between these features. This way of extracting features has been demonstrated to be effective in several text generation evaluation methods, such as Comet in text translation and Polos in image captioning. After the processing of the 2 branches, we concatenate the outputs of the 2 branches and feed them into 3 prediction heads, producing 3 evaluation scores. During training, the model learns to minimize the loss between these predicted scores and human judgments collected through subject experiments. By employing supervised learning, the metric is expected to align with human judgments. We also constructed long cap arena, since up to now there has been no public benchmark for long caption evaluation. In this benchmark, candidate captions averaged 101 words, and the human annotated reference captions averaged 131 words. This is about 9 times longer than standard benchmarks, which average 10 words. Also, candidate captions were generated with 10 different MLLMs on images from the DCI dataset. We collected a total of 32,000 human judgments from 1,000 annotators. We used this benchmark for our quantitative experiments on long caption evaluation. Here are the quantitative results on long cap arena. We compared VELA with 18 existing metrics using correlation with human judgments. As highlighted in green, VELA surpassed CIDR, Deneb, and FLIR, and it also outperformed an LLM-as-a-Judge based on GPT-4o. Moreover, VELA was comparable to human evaluation. In addition to this, the rightmost column reported per sample evaluation time. VELA was 5 to 8 times faster than existing LLM-based metrics. Considering both performance and speed, VELA can serve as a practical alternative to existing automatic metrics and even human evaluation. Here is a qualitative example. We input the image on the lower left to instruct LIP and obtain the candidate caption shown above. The image actually contained a single airplane in flight, but the candidate caption hallucinated details such as with its wheels still on the ground and 2 smaller airplanes present in the scene. And it also lacked detail compared to the reference captions. On the lower right, we show the evaluation scores out of 100 from GPT-4o, VELA, and human judgments. Compared to GPT-4o, VELA output evaluation scores that were closer to human judgments. For descriptiveness, human judgments were 75, and VELA produced 70. For relevance, human judgments were 50, and VELA output 59. These results demonstrated that our proposed metric was better aligned with human judgments. To conclude, we propose VELA, a long caption metric based on LLM-Hybrid-as-a-Judge. VELA was 5 to 8 times faster than conventional LLM-as-a-Judge methods. VELA achieved state-of-the-art performance and even outperformed human evaluation. We also constructed long cap arena, a benchmark specifically designed for long caption metrics. On average, the captions in this benchmark were more than 9 times longer than those in existing datasets, with over 100 words per caption. In total, we collected 32,000 human judgments from 1,000 annotators. You can access both VELA and long cap arena through this QR code. Thank you.